Hey everybody, Mr. Oglesby here. Today we are going to be going over math and measurements, and specifically we're going to be focused on metric conversions. Um, Now, when we get into this, there's some things that you need to make sure that you have. First off, you need to make sure that you've got the notes for today, something to write with, and then if you want some paper to do some extra notes if you need to do that. Okay. So let's go ahead and get started with our notes. So for this, what is chemistry? Before we actually dive into the metrics, let's talk about chemistry. Chemistry is what we call a physical science. So chemistry is going to tell us a little bit about the world that we've got and what's actually going on inside of it. Okay. Specifically, the atoms and the ground and the earth and those kind of things, not necessarily the living stuff as much, but we do still talk about the living stuff because guess what? Our bodies have chemical reactions happening inside of them all the time. Okay. So what is chemistry? Chemistry is a physical science. It's going to study what happens with matter and how matter changes. Okay. So for a better understanding, the previous definition, which again is kind of general, right? The study of matter and its changes can be separated into three big parts, okay? The first thing is that we talk about the composition or structure and properties of matter. So basically what we're looking for is we're trying to figure out how everything goes together, right? So what makes everything stick together? The next thing we talk about is the changes that matter undergoes, okay? And with that, we're basically saying what's happening when those things actually do stick together, okay? The last thing we talk about is the energy that's going to accompany those changes, all right? And basically, that's how we would use the chemistry in our everyday world, okay? So that's kind of how we can break down chemistry in general, all right? And so we're in a chemistry class, so let's actually talk about those things that are occurring. So we're going to start with the metrics. Now, in America, we use what's called the imperial system, okay? And that's talking about inches and feet and miles and ounces and pounds and those kind of things. I personally really do not like the imperial system. And the reason is it doesn't make any sense. The example I'll give, okay, if we're talking about length, okay, so in the imperial system, IMPERIAL, in the imperial system, if we're talking about length, we're going to be talking about inches, and then feet, and then miles. And technically, I guess I skipped yards, and that's because I don't use the imperial system very often. So yards and then miles. Okay, so there are 4 units that we use. Okay, well, first off, let's talk about an inch. Okay, an inch is about the size of the first segment of my thumb. Okay, so not very long, but also not very small, right? So there's not really a little small thing that we could really measure with a thumb, okay? Now, to go from inches into feet, it takes 12, okay? Okay, we could get along with that. There's a part of math called the base 12, right? So we could go with that. All right, well, now let's go from feet into yards, okay? Well, a foot is really, it's probably about the size of the screen for me, which is a little bit wider than my head. Okay, because I've got a big head. So a foot it's a pretty decent step up from inches. It could work. But if we go from feet into yards, well, that takes 3. Okay, well, if we're going to go with that, then we're dividing it by 4 every time, right? Okay, so divided by 4. Okay. So then the next one we would assume is that miles would be 3/4 of a yard if we kept that up, okay? Well, a yard is obviously 3 times as big as a foot, right? So that's going to be the stripes that you would see on like a football field, okay? Each one of those would be a yard. Now to go from a yard into mile, do you know this? Yards to miles. Okay, well, probably most of you don't know this because guess what? It's not taught because it doesn't make any sense because it's a random number. If you're guessing, it's not 3/4 of a yard. It's actually 1,760 yards in 1 mile. Okay, so we went from 1 inch, and then it took 12 inches to go to a foot, and then it took 3 feet to go into a yard. Okay, we're getting smaller, and then all of a sudden, 1,760. Okay, it doesn't make any sense, right? Whereas if we're talking about the metric system, what we're going to see is that every single time it's going to go up by a factor of 10. Okay, so in the metric system, we talk about, metrics, we talk about a meter a lot of times. Okay, well, a meter is a little bit longer than a yard. Okay, slightly longer. Okay, if we want to get larger than a meter, we can do what's called a decameter. And a decameter is 10 times bigger than a meter. If we want to get larger than a decameter, we can get what's called a hectometer. And it takes 10 decameters to get into 1 hectometer. And then we can go into a kilometer, which is again 10 times bigger. Okay. If we go in the other direction, we can go down to a decimeter. And then that would be 10 times smaller than a meter. And then we can go from decimeter down into centimeter. And then again, 10 times. So every single time with the metric system, it's always going to be either 10 times larger or 10 times bigger, or smaller, sorry. 10 times larger or 10 times smaller, okay? So it doesn't make sense for us to use the imperial system in science because, well, one, there's only 2 other countries in the world that use the imperial system, right? The majority of countries in the world actually use the metric system, again, because it just makes sense, okay? So the metric system is all going to be showing us everything in factors of 10, okay? Let's increase it by 10. Let's increase it by 10. Let's increase it by 10. Every single time, we're going to see it increase by 10. So we use it in the science community because it just makes sense, okay? So the metric system has been around for a really long time. Okay, it's been used since actually 1795, and again, it was used to indicate distance from the base unit. Okay, we add those prefixes to it, and they just tell us it's 10 times the previous unit. Okay, the prefixes are going to indicate whether or not the measurement is more or less than the base, and by how much. Okay, 10, 100, 1,000, 10,000, and so on. Okay. So here are the metric system prefixes, okay? So I've got giga, mega, kilo, hecto, deca. Then this right here would be where you find your base. Then it's deci, centi, milli, micro, nano, and pico, okay? The important ones for our class are kilo, and we'll sometimes use hecto, but I'm not going to say it's super important. Your base unit is definitely very important. Deci, centi, milli, and actually deci's not used all that often. So centi and milli are used a whole lot. And then we will actually talk about nano as well. Okay? So really, in the grand scheme of things, the most commonly used prefixes in chemistry are kilo, the base, centi, milli, and nano. Okay? So those are the ones that are you absolutely have to know how far they are apart. Okay. So how do I remember how far these are apart? Well, for me, I have always done a saying. Okay? And I think probably some of y'all have heard this saying. The saying is, King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. So, King stands for kilo. Henry is hecto. Died is deca. By would be where your base is. Drinking chocolate milk. Okay, so King Henry died by drinking chocolate milk. If you can remember that saying, then you can figure out all of your prefixes that are 100% important for chemistry. Okay, now there is one that I would say is actually past that saying. Okay, but once you get outside of this saying, every time you're increasing by a factor of 1,000. So it's three zeros past. Okay, so if I'm like at millimeter, then to get down to micrometer, it's going to be 3 more decimals past that. Okay. All right. So King Henry died by drinking chocolate milk. You can also look at these exponents right here, and these are another way that you could remember them. But this really does fall on you memorizing your exponents. I a lot of times don't suggest this because it can be confusing if you're not paying attention to where your exponents are going. Okay. All right. So how do I use that King Henry died by drinking chocolate milk? Well, if you remember it, it is King, so you'd write K. Henry died by drinking chocolate milk. So you write KHDBDCM. Okay, that's going to help you here in just a second. Okay, now I'm asked to actually convert these things from, for instance, this one is to go from kilograms into grams. So here's how you do that. Okay, so I've got kilograms. Well, kilo is my prefix, right? So I'm starting here at kilo, at the K. And I'm trying to go to grams. Well, grams is what? Grams is my base unit. Okay, so since it's my base unit, I'm trying to go to here. So I'm trying to go from the K down to the B. Okay, so I'm going to go 1, 2, 3 times. I moved it 3 times. Which direction did I move it? I moved it 3 times to the right. Okay, so since I moved it 3 times to the right, what I do is I come back to my number. I find that decimal and I move it 3 times to the right. So I take my decimal, 1, 2, 3 times to the right. So my number would be 7.82 grams. Okay, that would be my answer there. Okay, now let's go through another one. I'm going to erase my little loops right there. So I have 10.423 kiloliters, and it wants me to go from kilo to liter. Well, liter is again my base. A big way to look and see if it is the base is if it doesn't have 2 letters. Okay, right there, there's only 1 letter, so it's probably going to be my base unit. There are a few exceptions, but those won't happen until later on in the year. Okay, so if I have 2 letters, we're going to assume that it's got a prefix. Kilo has a prefix. It is K. Liter is my base unit, so B. And I'm going to take that and I'm going to go 1, 2, 3 times, and I went again to the right. So I went 3 times to the right, so I take my decimal and go 1, 2, 3 times to the right. So I have 10,423. So that's how you do your metric conversions. So what I want you to do right now is to pause and work through these next problems, these next 6 problems. And then when you finish, unpause it, and I'm going to show you all the answers. Okay? So go ahead and pause. Okay, hopefully y'all paused it. So now let's actually look at these problems. So the next one, which was 114 hertz. Now this is actually one that would have 2 letters, even though it's the base unit. Okay, but we've got hertz, all right, and we're going to megahertz. Well, hertz is my base. So I'm going from the base and I'm going to mega. Okay, well, mega is actually past kilo. Okay, so let's double check up here. So mega is actually the next one up from kilo. And again, I told you if it's outside of this range, you increase it by 3. Okay, so if I'm going from hertz, which is my base unit, to mega, which would be, again, 3 past kilo, 1, 2, and then mega. So I'm going to go 1, 2, 3, 4, 5, 6. Now, when I did that, which direction did I move? I moved to the left. So I'm going to take it 6 times to the left. So I was at 114. I took that decimal and I went 1, 2, 3, 4, 5, 6. Put your decimal where it was and then fill the zeros in for each of those loops. Okay? All right, next one here, we've got 0.000007895. On the next, we've got 6,040. Then we've got 0.000211529. The next one is a long one, 0.00000000000, so 12 zeros, 5375. And then last, we've got 16,420,000. Okay. Let us know if you got any questions. Shoot us an email. And hopefully y'all are doing great. And I can't wait to see y'all's faces. Bye.